Canfranc Station. For decades, moving heavy industrial freight and passengers between France and Spain meant navigating the treacherous passes of the Pyrenees Mountains. But the real bottleneck wasn't the steep geography. It was a foundational industrial failure. France and Spain had built their national railway networks using completely different track gauges. A French train physically could not roll onto Spanish steel. Every ton of international cargo had to be stopped at the border, unloaded by hand in the freezing alpine weather, and moved to a completely different train. To solve this supply chain nightmare, the two nations carved a plateau into the mountains and built Canfranc International Station. Opened in 1928, it was a colossal palatial megastructure stretching 240 meters long, built exactly on the border to serve as a unified, weatherproof transfer hub. Today, the site is famous for rumors of stolen wealth and Second World War espionage, but Canfranc's true undoing was a mundane engineering discrepancy: the distance between two steel rails. The station did not actually fix the track gauge problem. It only put a spectacular roof over it. The operational principle was a massive enclosed break-of-gauge transfer. Standard gauge French trains pulled up to one side of the vast central platform, while wider Iberian gauge Spanish trains docked on the opposite side. Workers and heavy cranes still had to manually lift, drag, and shift all the freight across the platform from one train to the other. By enclosing this process inside a single massive building, engineers solved the weather problem, but they permanently cemented a labor bottleneck. When the Second World War erupted, this highly centralized, isolated choke point became the perfect tool for state control. Because every single crate, asset, and passenger had to physically stop and change trains inside the building, the station became a tightly controlled nexus. Spies, refugees, and crucial industrial tungsten moved north into Europe, while an estimated 86 tons of plundered Nazi gold moved south. But wars end, and inefficient infrastructure remains. By the mid-20th century, modern shipping required seamless, high-speed logistics, not manual transfer platforms. Canfranc was already bleeding money when a minor freight train derailment in 1970 destroyed a crucial access bridge on the French side. It was all the excuse the railways needed. The bridge was never rebuilt, and the grandest station in Europe was abandoned to the snow, defeated not by conflict, but by the relentless inefficiency of incompatible steel rails. Maunsell Sea Forts. In 1942, the German Luftwaffe was exploiting a glaring geographic blind spot in British air defenses. Enemy bombers were flying at low altitudes directly up the wide, dark expanse of the Thames estuary, bypassing early warning coastal radar to strike London. Standard coastal anti-aircraft guns could not fire far enough to reach the open water. The military tried using ships, but a vessel rolling in the sea swells was far too unstable to serve as a precise, permanent artillery platform. Britain desperately needed a stable firing line out in the water. The answer was the Maunsell Army forts. They look like the rusted remnants of an alien invasion, but these sea forts solved a very terrestrial problem: how to put a heavy artillery battery in the middle of the ocean. Designing a fortress at sea is difficult. Constructing it over open water under the constant threat of enemy fire is almost impossible. Civil engineer Guy Maunsell bypassed the problem completely through extreme prefabrication. Each Army fort was organized as a sprawling cluster of 7 interconnected steel towers, housing searchlights, control centers, and heavy guns, with each individual tower weighing roughly 300 tons. The engineering breakthrough was how they were deployed. Instead of driving pilings deep into the seabed, each massive tower was built on shore sitting atop a hollow, reinforced concrete pontoon. Tugboats then towed these floating behemoths miles out into the treacherous, shifting sandbanks of the estuary. Once a tower was perfectly positioned, workers deliberately flooded the pontoon. The massive concrete base sank to the bottom, gripping the sand and leaving only the towering steel legs and armored gun decks protruding above the waterline. This mechanism created an immovable, rock-solid firing platform. Isolated crews lived inside these cramped metal boxes for weeks at a time, tracking low-flying targets and successfully shooting down dozens of enemy aircraft and 30 V-1 flying bombs before the war ended. The forts changed wartime defense, but their true industrial legacy was proving that massive, heavy-duty platforms could be successfully pre-built, towed, and sunk offshore, a technique that laid the groundwork for modern deep-water oil rigs. Decommissioned in the 1950s, the forts were abandoned to the salt and wind. Because they sat in a legal gray area regarding territorial waters, several towers were hijacked in 1964 by rogue broadcasters. They transformed the rusted anti-aircraft decks into outlaw pirate radio stations, blasting rock and roll beyond the reach of British law. Today, the surviving metal towers remain stranded in the fog, slowly rotting into the sea. Kadykchan. Deep in the Russian Far East, the abandoned settlement of Kadykchan looks as though its inhabitants simply vanished. Winter coats still hang in rotting closets, Soviet textbooks sit open on school desks, and teacups remain on tables. To extract coal in the brutal Magadan region, where winter temperatures routinely plunge to minus 50 degrees Celsius, engineers had to solve an impossible survival problem. Individual wood or coal furnaces inside thousands of separate apartments were completely inadequate against that level of lethal, sustained cold. To keep a workforce alive, the state built a monogorod, a single industry town entirely dependent on a centralized life support system. Internet urban legends claim Kadykchan was abandoned due to a mysterious disaster or a classified government cover-up, but the truth is much colder. A town of 10,000 people was ultimately killed by a frozen water pipe. The town relied on a district heating system known as a teplaset. Instead of every building generating its own heat, a single massive industrial boiler, continuously fed by the local coal mine, pumped highly pressurized, superheated water. This water flowed through a vast network of heavily insulated surface pipes, circulating continuously through every concrete apartment block and public building in the city. As long as the coal flowed, the water moved, and the town survived. But this hyper-efficient design created a fatal single point of failure. Following the collapse of the Soviet Union, Kadykchan's isolated economy began to crumble. Then, in 1996, a devastating underground explosion killed 6 men, and the unprofitable mine was permanently shut down. Without the mine, the central heating plant lost both its financial subsidies and its physical fuel supply. The moment the massive municipal boiler went quiet, the Arctic environment went to work. The heated water stopped circulating. Within hours, the static water inside the network froze and expanded, violently shattering the municipal pipes all at once. Kadykchan was not abandoned slowly through economic attrition. It was evacuated in a sudden, freezing panic. With the life support grid instantly destroyed and entirely beyond repair, the residents had to flee the plunging temperatures, leaving their fully furnished lives behind to freeze in the dark. Fordlândia. In the 1920s, the booming global automotive industry was entirely dependent on a single botanical resource: rubber. Without it, there were no tires, no engine belts, and no finished cars rolling off the line. But there was a massive supply chain bottleneck. British and Dutch cartels held a strict, highly organized monopoly on the world's rubber plantations in Southeast Asia, aggressively squeezing American manufacturers on price. Henry Ford absolutely refused to remain dependent on a foreign monopoly. He wanted total vertical integration, controlling every single material from the iron mine to the showroom. To bypass the cartel, Ford looked to the natural birthplace of the rubber tree. In 1928, he secured a staggering 2.5 million acre land concession deep in the Brazilian Amazon. He built Fordlândia, a massive, prefabricated American industrial town dropped directly into the jungle, complete with Detroit-style factory buildings, paved roads, and towering steel water tanks. People view Fordlândia as a lost jungle mystery, but it was actually a massive supply chain experiment that proved you cannot treat a rainforest like an assembly line. The project failed because Ford engineers attempted to apply the logic of a steel stamping plant to a living ecosystem. In the wild Amazon, rubber trees naturally grow far apart from one another. This wide, random spacing acts as a biological defense mechanism against the South American leaf blight, a highly destructive native fungus. But Ford's managers wanted industrial efficiency. They cleared the native jungle and planted the new rubber trees tightly together in neat, dense, factory-like grids to maximize latex yield per acre. By packing the trees shoulder to shoulder, they accidentally created the ultimate transmission vector. The leaf blight fungus easily jumped from canopy to canopy. Because the dense planting allowed the blight to spread faster than any chemical treatment could suppress it, the fungus mutated and ripped through the entire plantation. This biological disaster was matched by intense human friction. Local workers violently rioted against uncompromising American management rules, which included mandatory Midwestern diets and strict alcohol bans in the sweltering jungle. The trees withered, the yield plummeted to zero, and Henry Ford ultimately abandoned the project, taking an estimated $20 million financial loss. Today, the rusting water towers and concrete husks of Fordlândia are being swallowed by the Amazon, a monument to the hubris of industrial engineering ignoring ecological reality. Pyramiden, the Svalbard archipelago, sits at an extreme 78 degrees north latitude, placing it closer to the North Pole than to Oslo. It is a jagged, icy wasteland where human survival is inherently difficult. Under a unique 1920 treaty, any signatory nation was allowed to extract the region's massive coal deposits. But operating heavy industry in the high Arctic was ruinously expensive. To turn a profit, a normal mining operation required a brutal, bare-bones survival outpost designed simply to pull rock out of the ground and ship it south. But during the Cold War, the Soviet Union did not just want coal. They wanted to project power and superiority directly next door to NATO-aligned Norway. So they built Pyramiden. Online explorers call Pyramiden an apocalyptic time capsule, but it was actually the most expensive billboard in the world, a coal mine that mined geopolitics instead of profit. To prove the superiority of the Soviet system, the state decoupled this industrial facility from the requirement of making money. They poured millions of rubles into constructing an extravagant, utopian mining town at the edge of the world. They housed a peak population of 1,000 workers in artificial luxury. The logistics required to keep this town running were staggering. Icebreakers and cargo ships constantly fought through the frozen seas to deliver heavy heating fuel and fresh food. To complete the illusion of paradise, the state even imported ships full of rich Ukrainian soil just so they could grow a sprawling, green grass lawn in the middle of the Arctic tundra, flanking a grand cultural center and a heated indoor swimming pool. As an actual coal mine, Pyramiden was deeply inefficient. The coal was difficult to extract, and the operation rarely turned a real profit. But the state happily subsidized the massive logistical losses because Pyramiden's true function was simply to exist as an ideological showcase. However, you cannot suspend the rules of accounting forever. When the Soviet Union collapsed, the infinite ideological subsidy vanished overnight. Stripped of its political funding, Pyramiden was suddenly exposed as a wildly unprofitable coal mine burning cash at the top of the world. In 1998, the final ton of coal was extracted, the generators were shut off, and the town was abruptly closed. Today, polar bears wander past the perfectly intact, freezing monuments of a town built not to conquer the Arctic, but to sell an illusion. Hashima Island. In the late 19th and early 20th centuries, a rapidly industrializing Japan desperately needed high-quality coal to fuel its new steel mills and imperial navy, but there was a massive geographic problem. The richest unmined coal seams in the Nagasaki region weren't inside a mountain. They were buried deep beneath the ocean floor. You cannot build a traditional sprawling mining camp on top of the open sea, and transporting miners by boat every day was far too slow and inefficient. To keep the furnaces burning, the workers had to live exactly where they worked. To reach the coal, the Mitsubishi Corporation bought a tiny, uninhabitable offshore reef, surrounded it with massive seawalls, and built Hashima Island. Today, it is known as a spooky, ghost island. But the real horror of Hashima was the brutal engineering required to pack thousands of people onto a tiny rock to dig under the ocean. The entire island operated as an extreme, self-contained vertical city and mining machine. To access the coal, engineers cut a vertical shaft directly down through the reef, plummeting up to 1,000 meters below the surface. From the bottom of that drop, a labyrinth of horizontal tunnels spiderwebbed outward for miles directly underneath the seabed. The work was terrifyingly dangerous, operating under the constant threat of collapsing sea roofs, seawater intrusion, and explosive gas pockets. Above ground, the human pressure was just as intense. To house the workforce directly over the shaft without the island washing away in a typhoon, engineers enclosed the civilian population inside Japan's first large-scale reinforced concrete apartment blocks. At its peak, an astonishing 5,200 people were crammed onto just 16 acres of land, making it the most densely populated place on Earth. Workers, their families, schools, and hospitals were stacked in suffocating narrow concrete canyons where sunlight barely reached the ground. The relentless demand for wartime production turned this concrete fortress into a site of immense human suffering. During the Second World War, the deep-sea tunnels were manned heavily by conscripted Korean and Chinese forced laborers, hundreds of whom died from malnutrition, exhaustion, and accidents. Hashima survived the war, but it could not survive the changing global energy economy. When cheap petroleum rapidly replaced coal in the mid-20th century, the incredibly expensive undersea mine became obsolete. In 1974, the mine was officially closed. The residents were cleared out in a matter of months, and the island was left to the wind and the salt. Today, looking exactly like a massive, ruined concrete battleship stranded at sea, Hashima remains the ultimate expression of industrial density, a testament to how far an empire will go to turn a tiny reef into a machine, only to instantly discard it when the fuel runs out. Wittenoom. Post-Second World War manufacturing had an insatiable appetite for insulation. Factories, shipyards, and booming suburban developments needed materials that could withstand immense heat without catching fire or breaking down. Traditional insulators were often heavy, expensive, or inefficient. The industrial world desperately needed a cheap, fire-resistant mineral that could be pulled from the ground and easily woven into everything from brake pads to building materials. The answer seemed to lie in Wittenoom, a remote mining town built deep in the spectacular red dirt gorges of Western Australia. The entire settlement existed to extract, mill, and export massive quantities of crocidolite, a highly sought-after mineral commonly known as blue asbestos. Online, Wittenoom is famous as the town Australia deliberately erased from its maps. But the real monster wasn't a government cover-up. It was the lethal physics of a miracle mineral. In the mid-20th century, the toxic byproduct of this open-air mining operation, the loose rock tailings, was treated like inert dirt. The mineral was so abundant that the town used the tailings to pave their driveways, roads, and even the local school playgrounds. But blue asbestos is highly friable. When the raw rock is pulverized by mining equipment, or simply crushed under the tires of a passing truck, it shatters into an invisible, airborne dust. This is where the physics become deadly. Unlike white asbestos, which features softer, curly fibers, blue asbestos fibers are perfectly straight, rigid, microscopic needles. When inhaled, these needles do not just sit in the lungs, they mechanically pierce and embed themselves deep into the pleural lining. Because the human body cannot dissolve or expel the mineral, this constant mechanical irritation eventually triggers lethal mesothelioma. The most terrifying part of the Wittenoom disaster was its latency. Because asbestos-related diseases take decades to develop, the workforce didn't start dying immediately. The mine was ultimately closed for unprofitability in 1966, but by then, a generation of miners and their families had already lived out their lives breathing the dust. Ultimately, more than 2,000 former residents and workers died from the exposure. When the government finally recognized that the asbestos needles were permanently trapped in the soil, they realized the landscape itself was an unfixable industrial weapon. They didn't just abandon the town, they legally degazetted it. By 2022, the last holdout resident was evicted, the power grid was dismantled, and the roads leading into the gorge were physically destroyed. Today, Wittenoom is nothing but empty scrubland blocked by brightly colored hazard signs, proving that some industrial mistakes cannot be cleaned up. They can only be quarantined forever. Duga. During the height of the Cold War, the United States and the Soviet Union possessed fleets of intercontinental ballistic missiles capable of destroying each other in just 30 minutes. But early warning defense systems faced a fundamental limitation of physics. Standard radar beams travel in a straight line. Because the Earth is curved, Soviet standard radar could only detect an American missile once it crested over the horizon, leaving military commanders with only a few terrifying minutes to react before impact. To buy more time, the Soviet Union had to find a way to see over the curvature of the Earth, detecting an exhaust plume the moment a missile cleared a silo in North America. Their answer was Duga. Hidden deep in the pine forests of Ukraine, it was a gargantuan, skeletal metal wall of steel antennas towering 150 meters into the air and stretching for hundreds of meters across the horizon. Conspiracy theorists claimed this massive metal cage was a mind control weapon or a weather manipulator, but its real purpose was to bend physics to cheat the line-of-sight limit of geometry. Duga was an over-the-horizon, or OTH, radar system. Instead of firing a straight radar beam out toward the curve of the Earth, Duga beamed a massive, incredibly powerful shortwave radio signal diagonally up into the sky. When the signal hit the ionosphere, a layer of electrically charged particles high in the atmosphere, it bounced back down like light hitting a mirror, striking North America. If it hit an American missile, the signal bounced back off the metal, up to the ionosphere, and back down to the massive receiver array in the Ukrainian forest. The mechanism was a brilliant hack of planetary geometry, but it was incredibly inefficient. To push a signal around the globe, Duga consumed massive amounts of electricity, which is why it was built within sight of the newly constructed Chernobyl nuclear power plant. Furthermore, this brute force transmission severely disrupted civilian radio broadcasts across the planet. Amateur radio operators worldwide could hear a repetitive 10 Hz tapping sound drowning out their signals, earning the mysterious array the nickname the Russian woodpecker. Despite its immense scale and power, the system was plagued by constant atmospheric interference. By the late 1980s, the brute force radio bounces were rendered completely obsolete by a new, more reliable technology: orbital early warning satellites. Duga was officially shut down in 1989. Today, the towering steel wall still stands inside the Chernobyl exclusion zone. Unaffected by the radiation but rendered useless by progress, it slowly rusts in the forest, a colossal monument to a paranoid era when humanity burned massive amounts of power just to buy 20 extra minutes of warning before the end of the world. Centralia, Pennsylvania, was once a standard, prosperous American mining town built directly on top of massive subterranean deposits of anthracite coal. But the legacy of early 20th century mining left behind a dangerous geological footprint. Beneath the town lay a sprawling, multi-level labyrinth of abandoned tunnels and cavernous stripping pits that connected directly to the surface. Like many industrial municipalities of the era, the town saw these deep, open pits not as a hazard, but as a convenience. They used an abandoned strip mine pit at the edge of town as an unregulated municipal landfill, completely ignoring the direct physical connection between their daily trash and the unmined coal reserves directly beneath their feet. In May of 1962, the town council authorized a controlled burn of the landfill to clean it up ahead of a holiday weekend. Urban legends say Centralia inspired horror movies and ghost stories, but the town wasn't cursed by the supernatural. It was doomed by a garbage fire and a failure to respect geology. The fire inside the landfill was supposed to burn out in a day, but the pit contained a deep, unsealed opening that led directly into the abandoned mine network. The trash fire crept down through the opening and ignited the exposed face of the anthracite coal seam. Anthracite coal is incredibly dense and has a high carbon content. Once ignited in a low-oxygen subterranean environment, it does not blaze. It smolders with an intense, unyielding heat. The fire retreated underground, feeding on the massive remaining coal deposits. Crucially, the miles of abandoned mine shafts acted as a colossal ventilation system, perfectly feeding oxygen to the fire while allowing it to travel directly beneath the residential grid. As temperatures in the subterranean hotspots spiked to over 1,000 degrees Fahrenheit, the intense heat began fracturing the bedrock holding up the town. Lethal levels of carbon monoxide vented up through the soil into basements, and massive, smoking sinkholes suddenly opened beneath backyards and highways. Because the fire was so deep and the tunnel labyrinth so complex, flushing it with water or excavating the burning seam proved financially and physically impossible. After decades of trying to fight the unquenchable heat, the town was ultimately condemned via eminent domain, and nearly every building was demolished. Today, Centralia is an empty grid of overgrown streets with white smoke continuously rising from vent pipes. With enough coal left to feed the fire for an estimated 250 years, Centralia proves that when heavy industry permanently alters the geology beneath our feet, a single surface mistake can trigger an unstoppable subterranean disaster. Kola Superdeep Borehole. During the Cold War, the space race dominated headlines as humanity looked up, but a parallel scientific race was happening in the opposite direction. Geologists wanted to pierce the Earth's crust to reach the mantle. The industrial problem was profound. Standard oil drilling technology maxed out relatively close to the surface. Nobody actually knew how solid rock and heavy machinery would behave under the unprecedented temperatures and crushing lithostatic pressures miles underground. To push beyond these limits, the Soviet Union launched the Kola Superdeep Borehole project in the remote Murmansk region. The Internet loves the myth that the Kola borehole broke through into hell and recorded the screams of the damned, but the truth is actually much more terrifying. Engineers hit the physical limit where solid rock behaves like warm plastic. For decades, engineers invented new ways to lubricate drill bits and turn massive drill strings, slowly carving a hole that was just 9 inches in diameter but reached an astonishing maximum depth of 12,262 meters. It became, and remains, the deepest artificial point on Earth. But at that depth, the drill hit a literal wall of physics. Geologists had predicted the rock at 12 kilometers down would be around 100 degrees Celsius. Instead, the subterranean temperature spiked to a blistering 180 degrees Celsius, or 356 degrees Fahrenheit. At this extreme combination of heat and depth, the rock stopped behaving like solid stone. It became rheological, meaning it acted more like a highly viscous flowing plastic. This physical change defeated the machinery. Whenever the engineers had to pull the drill bit all the way up for maintenance or replacement, the intense surrounding pressure caused the walls of the hole to slowly flow and squeeze shut behind it. It was like trying to drill a deep hole through warm wax. The drill string simply couldn't fight the flowing rock. The planet healed the wound as fast as the machines could cut it. The drilling was officially halted, and the project was eventually abandoned as the Soviet Union collapsed. Today, there is almost nothing to see at the site except a heavy, rusted metal cap bolted to a concrete floor inside a ruined building. But the Kola Superdeep borehole stands as the ultimate limit of heavy industry. We have engineered machines capable of leaving the solar system, but the Earth's own thermodynamic forces prevent us from digging more than a tiny scratch into its surface.